Hello students, myself Professor Kale Supriya. I am from Computer Science Department, News Commerce and Science College. In last lecture we see the what is IT acts and the punishments and the hacking techniques, countermeasures and web application security. Now in this lecture in this session we see the database recovery and information security. In this session agenda we see points: purpose of database recovery, types of failures, then what is transaction log, data updates, data caching, transaction rollback, that is undo and roll forward, checkpointing, recovery schemes, then ARIS recovery scheme, recovery in multi-database systems. Firstly, what is the database? Database is nothing but the collection of related data, that is called as the database. If there is the data of some students, that name of that student, then percentage, class, address, mobile number, these are the data related to that students in that year. If we see the students of 2022, which is in FY or SY or TY, the data of that students is, we have the data of that student. That data is known as the database. And if the database or any bank having the database, the bank having their customer database, means that customer database having the customer name, account number, then the balance of that account number, if the FD is created or not of that customer, these are the database. And then if the any failure is in the database or the information loss in the database, this is the very dangerous for that system. Then how to recover from that database recovery? This is the topic, that is database recovery. In database recovery, what is the purpose of database recovery? In database recovery, to bring the database into the last consistent state which is existed prior to the failure. If any failure is occur in the system or in banking system, in that case the data which is at the last stage will be in that consistent state. That is nothing but the before failure, the data which is in that state will get that data in that state, that is called as the consistent state. To preserve the transaction properties, that is atomicity, consistency, isolation and durability. These are the four properties related to the transaction. Transaction is nothing but if we can deposit the money in the bank, this is one transaction. Or we can withdraw the money from the bank, this is one type of transaction. If any person account having the balance 10,000 and if he can withdraw the money from 5,000 from that bank account, then what is the balance? Now 10,000 minus 5,000, the total balance now in that bank account of that customer is the 5,000. And if in that case if any system failure is occur, the system, after the system recovery, we get the balance, that is nothing but the 5,000. That is nothing but our database is in the consistent state. For example, if the system crashes before a fund transfer, transaction completes its execution, then either one or both accounts may have incorrect value. If the transaction will be done and if the system crashes, in that case what the account balance will be having incorrect value. But the database must be restored to the state before the transaction modified any of the accounts. In database recovery, our bank account will be recovered. It will use the our before value, before the system crashes. It gives that value. Second, types of failures. The database may become unavailable for the use due to what? There are the three types of failures. First is transaction failure, second system failure, and third is the media failure. Transaction failure is nothing but the what? We know that the transaction is nothing but the, I have explained what is mean by if we can withdraw or deposit money. This is the transaction, means we can read the data or write the data. Read data means only read the data. Write data means some changes will be done in that data and then that data will be write to the database. Transactions may fail because of incorrect input or deadlock or incorrect synchronization. Transaction fails. Incorrect input, if anyone gives the incorrect input, in that case transaction may fall. If any deadlock, if the systems are waiting for each other, that is nothing but the deadlock or incorrect synchronization. If their timing will be wrong of that, all the transaction, in that case the transaction will be failure. Next, system failure. What is mean by system fail? System may fail because of the what? Addressing error or application error or the operating system fail or RAM failure. If the operating system fault will occur, or RAM means random access memory failure or any application error, in that case system failure will be occur. And next is the media failure. What is media failure? If the disk head crash or the power disruption, if the light is off, in that case what? The media failure will occur. This is the one transaction log is here. In transaction log, what will be here? In the transaction ID, then what is back P and next P point, that is previous and next log. What is previous log? Next log. Then operations, the data item, this is before image, after image. Before image means the data before transaction having the value x 100, and after transaction the x having the value which is in the database, that is 200, which is write to the database. This is transaction T1. This is also transaction T1. This transaction T1 is begin. Then transaction T1 writes the x value as a 200 to the database. Now transaction T2 is begin. Then again transaction T1 having the value y is equal to 50, and this modified value of y after the transaction, it is returned to the database, is the 100. After the transaction T1 again having the value of m, which is 200, which is returned to the database having the value m equal to 200. Now the transaction T3 have read the n, and after that having the n having the value 400, and which is returned to the database, that is 400. After that transaction T1 ends. Now after these transactions, the transaction x having the, after all the transactions will be completed, T1, T2, T3, in the database the x having the value 200, y having the value 100, m having the value 200, and n having the value 400. Before image and after image, that is before modifying and after modifying. Before modifying, x having value 100. After transaction T1 completes, now the value of x is 200. Now the database having the value 200. Okay. Now the data update. In data update there is the 4 updates. Immediate update. In immediate update, as soon as the data item is modified in cache, the disk copy is updated. If the data item is modified, again the disk copy is updated, that is immediate update. Next, deferred update. All modified data items in the cache is written either after a transaction ends its execution or after a fixed number of transactions have completed their execution. In immediate update, immediately data will be updated to the database. In deferred update, the data will be modified in the cache and it can return to the database if the transaction end or some limited number of transactions have completed. After that the data will be write to the database, that is deferred update. Next, shadow update. What is shadow update? The modified version of data item does not overwrite its disk copy but it is written at the separate disk location. In shadow update, in database directly does not update that value, but it can store or return that value or disk copy to the separate disk location. If any failure occurs, then that shadow update copy will be deleted. In place update, the disk version of the data item is overwritten by the cache version. In this also directly disk copy will be overwritten. These are the 4 updates. Next, data caching. What is meant by data caching? Data items to be modified are first stored into the database cache by the cache manager. When the data item will be modified or updated, this first is stored into the where database cache by the cache manager, and after modification they are returned to the disk. After modification they are returned to the disk. Flushed means return. The flushing is controlled by modified and pin unpin bits. Return is controlled by whom? Modified and unpin bits. Pin unpin instructs the operating system not to flush the data item, and modified indicates the after image of the data. Pin unpin असेल तर does not modify or update the data or value, and if modified can indicates the modified value will be returned to the database. Next is transaction rollback. That is nothing but the undo, and roll forward means redo. Undo or redo means nothing but the, in undo we can restore the before modification changes, and redo after modification changes. Suppose if a customer having a bank account in any bank, it having balance of 10,000. If he can deposit the money 5,000 in that bank, now the balance of that person is 15,000, and 10,000 is the value which is of before image, and the 15,000 is the value which is of after image. If any failure occurs and that 5,000 will not be deposited in the bank, then operation will be done? Undo. And if the account have added that 5,000 into that account, no system failure will occur. In that case, the current changes will be onto the disk. Database recovery is achieved either by performing only undos or only redos, or by the combination of the two. These operations are recorded in the log as they happen. Using these 2 operations we can recover the our database. Here is shown T1, T2, T3 are the 3 transactions. T1 reads atom A, atom D, and writes atom D. Transaction T2 reads atom B, writes atom B, read atom D, and writes atom D. Transaction 3 read atom C, then write atom B, read atom A, and write atom B. If any failure occurs, then all the transactions will be rolled back. This is nothing but the cascading rollback. If one transaction fails, then the transaction related to that atom all also roll back. This is nothing but the cascading rollback. Here this is here shown. T3 is rollback because it did not reach its commit point. Transaction T3 rollback because of it does not reach to commit point. Because of transaction T3, again T2 also roll back because it reads the value of atom B written by the T3. T3 returns the value of B, that is 12, and which is read by the transaction T2. But transaction T3 fails, so the B having the value as 15 does not add the changes value 12. So the transaction T2 which accept the value of T3 which is 12 updated by the transaction T3, again it T2 is roll back because of it also reads the value written by the T3. Because of system crashes, again these transactions are rollback. Here showing the execution of T1, T2 and T3 recorded into the log. T3 read C, write B, read A. Transaction T2 begins, read the value of B, write the value of B, again read the value of D, write the value of D. And transaction T1 read A, read D, write D. At this time the system crash will happen, and these all transactions will be rollback, which are related to each other or reads the data which is written by the transaction. Next is write ahead logging. What is meant by write ahead logging? When in place update immediate or deferred is used, then log is necessary for recovery and it must be available to recovery manager. This is achieved by the write ahead logging protocol. What is the for recovery purpose? If there is the immediate or deferred update is used, in that case we need the what write ahead logging protocol for recovery. Write ahead logging protocol states that what for undo before a data items, that means after image is flushed to the database disk, overwriting the before image, its before image must be returned to the log and then log must be saved on a stable store. Before image value will be stored. After image value means changed value, updated value. Before image value means before updated value. In this undo, we know that undo operations, in undo operation before image value will be stored. And for redo, before a transaction executes its commit operation, all its after images must be returned to the log and the log must be stored on the stable store. In redo operations, there will be after image data will be stored, that is updated data or changed data. Next, checkpointing. Time to time or randomly or under some criteria, the database writes its buffer to the database disk to minimize the task of recovery. Time to time, what happen? Database will write this data to the hard disk to minimize the task of recovery. If any failure occurs, in that case data will be lost. For that purpose, what the disk will buffer will write this data to the disk in some time to time manner. The following steps defines the checkpoint operation. What is checkpoint operation? Suspend execution of transactions temporarily. Some transaction execution will suspend for temporarily. We can stop the execution for temporarily. That is nothing but the checkpoint operation first. Next, force write modified buffer data to the disk. Up to that execution, which data will be modified, that data will be, the data in the buffer will be write to the disk. From that checkpoint, which data will be changed or updated, that whole data up to that checkpoint will be write to the disk from the buffer. Buffer is nothing but the temporary memory. Third, write a checkpoint record to the log, save the log to the disk, and then write that record to the log. After that, resume normal transaction execution and after that checkpointing to resume our transaction. From that checkpointing, next transaction or next instructions will be executed. During recovery, redo or undo is required to transactions appearing after the record. Next, till no till and force no force. Possibly ways for flushing, that means writing a database cache to the database disk. The temporary, our data in the temporary memory or cache memory, from that cache memory, the database, the data will be write to the what? Our database disk. Okay, for that the following ways. Still means cache cannot be flushed before transaction commits. What is our data in the cache cannot be saved to the database before the transaction commit. When the transaction goes to the commit point, at that point our transaction will be successfully completed and after that our data will be stored to the database. Second, no still, cache cannot be flushed before transaction commit. In that also same, cache can be flushed before transaction commit. Then no still means cache cannot be flushed before transaction commits. Force, cache is immediately flushed, that means write to the disk. In force, in the data in the cache or updated data in the cache will be immediately write to the disk. No force, cache is deferred until transaction commits. If the transaction is not commit, then the data will not be write to the database. This gives rise to the 4 different ways for handling the recovery. That is still, no force, that is undo, still means undo, no force, redo. Next, still, force, undo, no redo. No still, no force, redo, no undo. And no still, force, no undo, no redo. Next, recovery scheme, that is deferred update, no undo, redo. Means updated data will return to the database. The data update goes as follows. A set of transactions records their updates in the log. At a commit point under write ahead logging scheme, these updates are saved on the database disk. After a reboot from a failure, the log is used to redo all the transactions affected by this failure. If we reboot our system or after the failure, the log is used for what? To redo all the transactions affected by failures. No undo is required because no after image is written to the disk before a transaction commits. Here is the example shown here. An example of recovery using deferred update in a single user environment. The read and write operations of the two transactions and the system log at the point of flush. Transaction T1 read atom A, read atom D and writes atom D to the database. Transaction 2 reads atom B, writes atom B, read atom D and writes atom D. The transaction start T1, write atom T1 D 20. And now commit transaction T1. Now the value of D is 20. Now start of transaction T2, write atom T2 having the value of B 10 and the write atom T2, transaction T2 having the value of D, updated value, transaction T1 having 20. That transaction T2 gets the value 20 and adding the 5 in that value and having the value D 25. The write atom operation of T1 are redone. T2 log entries are ignored by the recovery process. Here the system crash will happen at the time of transaction T2 execution. In that case, the T2 is in that before phase and the only transaction T1 will be completed. Here the value of D is 20, not the 25, because the transaction T2 fails because of system crash. So the value of D will not be updated, only the having the before value, that is D equal to 20. Here the show deferred update with the concurrent users. Again transaction T1, T2, T3, T4 are the 4 transactions reading the values of A, then reading the value of D and writing the value of D. T2 reading the value of B, writing value of B, read atom D and write atom D. T3 also read atom A, write atom A, read atom C and write atom C. Transaction T4 read atom B, write atom B, read atom A and write atom A. Here the transaction log, transaction T1 is starting, then write atom T1 having the read the value of atom D, that is here only transaction T1 reads only the value of A and writing the value of D. D having now the database having the value of D as 20 and the transaction T1 is completed. Commit means it is successfully completed and now the we are having the value of D as 20. Here is the checkpoint. After checkpoint, transaction T4 will be started. Now transaction T4 writing the values of B and and A. B having the value 15 and A having the value 20. Now the transaction T4 is also successfully completed. So now the database having the values, value of D is 20, value of B is 15, value of A is 20. Now this is also commit T4 completely successfully completed transaction T4. Now the transaction T2 starts. After transaction T2 starts, it having the returns the value of T2 returns value of B and D. B having the value 12 and the transaction. Now here B having the value 12. So B value in database is 12. Now the start of transaction, but the transaction T2 is not committed, so it is not successfully completed. Now start transaction T3. T3 writing the values A as 30 and the writing the item value of D equal to 24. The transaction T2 and T3 both are not completed because commit point is not there. Here at that point the system crash happens. In that case T2 and T3 are ignored because they do not reach their commit points. So T4 is undone because its commit point is after a last system checkpoint. Again transaction T4 will be redo, but transaction T2 and T3 will not be redo. It will be in undo state. It cannot be completed. Default update with concurrent users. Two tables are required for implementing this protocol. We know two tables are active table and commit table. In active table, the transaction which is in active states will be stored, and in commit table, the transactions which are successfully completed, that will be stored in this commit table. During recovery, all the transactions of the commit table are redone and all the transactions of active tables are ignored, since none of their after images reached the database. It is possible that commit table transactions may be redone twice, but this does not create any inconsistency because the redone is the idempotent. In the commit table, the data will be redo. The transactions, if the system crashes, and the data in the commit table, all that transactions will be redone because that are successfully completed. But the transactions in the active tables are undo because the transactions before system crash will not be successfully committed or completed. So the transactions in the active table are undone and the transactions in the commit table redone. Recovery techniques based on immediate update. Undo no redo algorithm. In this algorithm, after images of the transactions are write to the database disk under write ahead log before it commits. For this reason, recovery manager undoes all the transactions during recovery. In this algorithm, no redone will be take place. Here only undo will be take place. Undo is nothing but the values or images before a modification. Values of that data items before modification, that is undo. It is possible that transaction might have completed execution and ready to commit, but this transaction is also undone. Undo redo algorithm. The recovery manager performs undo of a transaction if it is in the active table and the redo of the transaction if it is in the commit table. And undo redo algorithm for concurrent execution. In this, undo of a transaction if it is in the active table and redo of transaction if it is in the commit table. This recovery scheme applies undo or redo to recover the database from failure. In concurrent execution environment, a concurrency control is required and the log is maintained under write ahead logging. Commit table records transactions to be committed. The transactions which are committed successfully completed will be in the commit table, and the active table all the transactions which are active, that is currently running. The shadow paging is nothing but the The after image does not overwrite its before image but recorded at another place on the disk. This is at any time the data has after image and the before image at two different places on the disk. That is, the data updated, before data updated and updated data, these are the two data will be stored at two different places. That is 10,000 and 15,000. Before deposit amount or balance of that person is 10,000. After deposit of 5,000, the balance of the data that person is 15,000. These are the two data before updation or before deposit and after deposit. These two values will be stored at two different places. That is nothing but the shadow copy of data item. The ARIS recovery algorithm. The ARIS recovery algorithm consists of three steps: analysis, redo and undo. In analysis step, what happens? This step identifies the updated pages in the buffer and the set of transactions active at the time of crash. The appropriate point in the log where redo is to start is also determined. We know that redo operation is necessary to apply. Undo, log is scanned backwards and the operations of transactions active at the time of crash are undone in the reverse order. Analysis, redo phase and undo phase. And last, recovery in multi-database system. Multi-database system is a special distributed database system where one node may be running relational database system under the Unix and another may be running object-oriented system under Windows. If there is a two databases which are on the two different systems, one is on the Unix, another is on the Windows, a transaction may run in the distributed fashion at a multiple nodes. In this execution scenario, the transaction commits only when all these multiple nodes agree to commit individually the part of the transactions they were executing. These two nodes having their permissions for execution, and this commit scheme is referred as two-phase commit, 2PC, that is two-phase commit. If any one of these nodes fails or cannot commit the part of the transaction, then the transaction is aborted. Abort means rollback. Each node recovers the transaction under its own recovery protocol. Next point is 5 ways on how to destroy documents securely to prevent a data breach. Means our data, how to secure our data. We should properly destroy the sensitive documents by learning how to destroy documents or prevent our data. That means confidential documents are those which are unsuitable for the general public or those do not directly related to the case to have access to. They may be personal information about a client your firm has represented. Depending upon the line of work, you may have a variety of confidential documents. How to destroy that confidential documents after a certain period of time, according to the Health Insurance Portability and Accountability Act of 1996. How to destroy the documents, both physical and virtual. Physical means our hard copy and virtual means our soft copy. First is shredding a sensitive document. Shredding is nothing but the shredder is nothing but the one machine which can cuts our documents into the small pieces and anyone cannot read the data on that papers. Gain access to a cross-cut shredder. This protects you from would-be thieves of this information from reconstructing the complete pages from the strips. When shredding sensitive documents, it is important to use the cross-cut shredder because it produces thinner strips of paper. Using cross-cut shredder, our paper documents will be cut into the smaller pieces. Then shred that documents. Once you have to satisfactory shredder, you must know how to destroy documents by begin sending all of your documents through the device mouse. Continue until all of your documents are done. If you have more documents than the machine can hold at one time, but sure to take the ribbons of paper out before continuing. Next, separate the pieces into separate bags. Take the portion of each document and place them into the separate bags. After the cutting these papers into the small pieces, we can put into the separate bags. Beyond reducing them to unrecognizable small pieces, this is one further security measure. This way, any would-be thieves cannot find matches within the same bag. They will have to sort through everything. Then dispose of them onto the scheduled day. We can dispose that on the, we have to day. Dispose of them on the scheduled day. आपण जो scheduled day केलेला आहे, we can dispose on that day. Next, pulping sensitive documents. Pulping is nothing but what? Place the documents into the large trash can. We want to container tall and wide enough to easily contain all the documents and liquids you are pulping. Similarly, material need to strong enough so that it won't deteriorate or lose it from when it contact with the bleach and water. Since you will be using roughly 22 liters of liquid to dissolve the documents, choose a trash can that is greater than or equal to 30 liters. We can dissolve our documents into the hot water using the bleaching. Pour in 1/2 of gallon 2 liters of bleach. Many stores sell brand name and generic bleach with a 8.25% concentration. This is perfect for your purpose. Bleach is going to help break down the paper. This will guarantee a more complete destruction of any secure information in your documents. Our information will be securely destroyed. Next, add 5 gallons 19 ml of water. Although bleach is the more chemically harmful and stronger part of this mixture, simple water is doing a lot of the work. Once the paper is completely saturated, we will be able to reduce it into the unrecognizable pulp. Then push the documents down into the bleach water. Then let the documents sit for the 24 hours. After waiting 24 hours, the document should be soft and discolored. Using an electric mixture, blend the paper until it becomes a soft uniform mesh. Lay out into sunlight to dry. After that, dispose of the pulp. Next, third is burning the sensitive documents. We can set up an outdoor fire pit, then start the fire and place that sensitive documents in the fire. Then check the ash, burn any remaining pieces if remain, and then scatter the ash. And fourth, destroying the virtual documents. How the virtual document? We know that delete the documents or overwrite the hard drive or degas the hard drive to destroy or delete our documents. And now the physically destroy the hard drive or permanently delete the emails or clean your browser history. Next, hiring a company. Using a company, you can hire the company for destroy the documents. And last, we see the what is database recovery, then types of failures, transaction log, database updates, then data updates, data caching, transaction rollback, that is undo and redo, then checkpointing, recovery schemes, ARIS recovery scheme and recovery in multi-database system, and information destroying. These are the summary. Thank you.